Hi, thanks for joining and welcome in this session about OpenJFX, where we will give a status update about Java on the client. So let's first of all quickly start with a high-level overview of what exactly is JavaFX. So JavaFX is mainly the client-specific implementation and APIs of the Java APIs for user interface development. It contains UI specific APIs, but also some more generic APIs that are very useful on clients in general. It is not part of the JDK 17 release, which is defined in GSR 392. So it's in general not part of OpenJDK distributions. However, OpenJFX, which is the repository where JavaFX is being developed, is part of the OpenJDK organization. And by being part of the OpenJDK umbrella organization, the OpenJFX project can leverage many principles that are applied to OpenJDK as well. So we share some of the development structures, the concept about roles, reviewers, committers, project leads, and so on, and also the infrastructure, which is quite an important benefit because OpenJDK, as you might know, is using the Scala tools that provide additional functionality over the traditional GitHub interfaces, which is a real benefit for achieving high quality in commits, pull requests, and so on. So it is developed on GitHub. The code is on GitHub, and the URL is github.com/openjdk/jfx. The license is similar to the license of OpenJDK, which is GPL plus a class path exception. And it is very important to realize that JavaFX is really community driven. So this is not a strategic project from one big company. This is really the Java community that is behind this. So let's have a quick look at how a typical JavaFX application may look like. What you see here is almost the most simple example that we can come up with, but it already shows some of the contents of JavaFX. So I think the first thing that you might notice from this is that this is really a Java application. So JavaFX, and I can't stress this enough, is really Java. If you know Java, you know JavaFX. It has a number of packages in the JavaFX namespace that provide the APIs that you can use. And the application that's being developed here extends the JavaFX application, which provides a limited number of methods. And the start method is the one that will be executed by the Java runtime if you start the JavaFX application. In this application, we will create an image which is created from a resource, and that image is then rendered along with a label, which is one of the controls components. We put those the image view and the label together in a stack pane, which is a layout component, and we render that in the stage that will actually do the rendering in a window. And the result is what you see on the right hand side of this slide. So it's an image and some text. So this is the most simple application that you can think of, and it probably looks pretty familiar to Java developers. So without going into detail about what exactly the programming model of JavaFX look like, this is not a tutorial in JavaFX. It's I think important to understand that JavaFX contains a number of controls in the JavaFX scene control package, and a number of basic layout containers, which are in the JavaFX scene layout package. Apart from the controls and the layout, it's good to know that JavaFX uses a scene graph model for setting up a user interface and for rendering that user interface. The rendering itself is done by the framework. So this is quite different from AWT and Swing, for example, where the user was responsible for making sure that the changes applied to the components were rendered. In the case of JavaFX, there is to simplify things a little, there is a background thread that is constantly looking for changes in the scene graph, and if there are relevant changes, those parts that need to be re-rendered are re-rendered. So that is done by the JavaFX internal framework. The application that I showed on the previous slide is a programmatical example of how JavaFX can be used. Many people prefer to use JavaFX in a more declarative approach, where they use Gluon Scene Builder for declaratively define the user interface and set the properties and so on. And you can also use CSS for styling the JavaFX applications. So Scene Builder is an extremely popular tool where you can drag and drop different controls, layouts, the built-in controls, but also third-party controls, so your own controls can work inside Scene Builder. And you can set up the user interface that you like to have, and you can define the different properties. For example, you can define the margins, space, font size, and then more specific properties for different controls. And you can also provide the binding to the code. For example, if someone clicks on this button, then I want this method to be called in code. And that is, of course, very useful if you want to separate the design phase from the programming phase. So a designer can work with Scene Builder on the user interface, and the developer can implement the logic behind the code bindings defined by the designer. You can get Scene Builder from the link below, gluonhq.com, products Scene Builder. So how do you create a JavaFX application? There is support for the major IDEs, NetBeans, IntelliJ IDE, and Eclipse, for example. They have specific JavaFX plugins, but also they all have support for Maven, and because JavaFX has a very simple Maven plugin, it's very easy to use JavaFX in your favorite IDE. Roughly speaking, there are two major approaches that people use. First of all, you can download JavaFX as an SDK, similar to how you download the Java SDK. And that SDK then contains the JavaFX modules and everything that is needed to run JavaFX applications and to build them, which include platform-specific native libraries. So that is the approach similar to how the Java SDK is downloaded and used. But you can also use Maven or Gradle with the JavaFX plugins, where you just define JavaFX, the JavaFX modules as dependencies in, for example, the pom.xml. So there you define that your application depends on JavaFX.controls 1702, for example, and then Maven will download, will make sure that you can use these modules, and everything is done by Maven and by the plugins, so you don't need to worry about that. If you want to get started, the best recommendation that I can give is going to OpenJFX.io/OpenJFX docs, where you will see the different approaches and where you can also learn about how to take advantage of your IDE if in case your IDE has specific support. So I think it's important to explain why JavaFX is the way it is, because we often got many questions about why is JavaFX doing this? Is it possible in JavaFX to do that? And it's, I think, it's probably a good idea to explain what are the boundaries of JavaFX. So what are the restrictions and what are the ambitions? And the number one property of JavaFX is that JavaFX is really pure Java. And as in case you remember, originally Java had a user interface component as well, which was provided by AWT, the Abstract Windowing Toolkit, and Swing. And that was released in the late 90s. And between the late 90s and today, there have been many changes in the user interface development. Not only in the software, of course, there are new software paradigms, there are new drivers, but also the hardware has changed. GPUs are now much more common and extremely capable and powerful. And every modern user interface component at least tries to benefit from GPUs. And the programming paradigms have changed as well since AWT and Swing were created. So in order to address those new things in UI development, Sun Microsystems, who was at that time the steward of Java, created JavaFX. And JavaFX addresses those changes and in the low-level UI development, and is therefore much more future-proof than previous UI frameworks in Java. And since it is still pure Java, it also means that the properties, the benefits, and the requirements for Java apply as well. So being Java means, and we will go over those 4 points in the next few slides. Being Java means that we have to adhere to the write once, run anywhere paradigm of Java. You want your code to be written once and to be executed on different platforms. Java is also known for its stability and maturity, and Java is very predictable. With predictable, we mean here the release cycle, the versioning, and so. And Java itself is actually much more than just a programming language or whatever is contained in the JDK. Java provides the foundation for third-party libraries. The ecosystem is one of the things that make Java great and make Java used by so many other projects. So write once, run anywhere, or WORA. What does it actually mean for a user interface? We know if you're a Java developer, you know what it means for Java. It means that your application runs on Windows and Mac and on Linux without you having to recompile the application. But what does it mean for a user interface? It's often more challenging because it means that your user interface needs to run on different platforms. That means different operating system, for example, on Windows, Linux, and Mac OS. But there are more operating systems than just those desktop operating systems. It means that your user interface will also run on iOS devices, Android devices, and Raspberry Pi operating system, for example. So that is one of the great things about JavaFX. It is really WORA, and it really makes it possible to run your applications on any on the user interface of any major operating system. Apart from the operating system, there are even more differences in the landscape of user interface development. And there are many different windowing and toolkit systems around, for example, X11, Wayland, GDK, GTK, or in case that there is no window manager, which is often the case on embedded devices where DRM is used. All of those approaches are supported by JavaFX as well. And then there are different low-level rendering approaches that are taken by some operating systems, some window managers, some combinations, some drivers, and so. For example, OpenGL is still being very popular, Direct3D on Windows, Metal, the new thing for Apple systems. and software rendering, which is always a good fallback scenario. So those are all different implementations of JavaFX that a JavaFX developer does not have to worry about, because JavaFX as Java is write once, run anywhere. And it is a JavaFX runtime that will make sure that your JavaFX application runs on those different operating systems, windowing, toolkit combinations, rendering approaches as well. So that is for the developer, I think, a great advantage. We know that Java is known for its stability and maturity, and with JavaFX, this is no different. In Java, it's extremely important to be backward compatible, and this is something that we take very serious with JavaFX as well. If you write the JavaFX application today, you really want it to run it in 5 or 10 years from now as well. So you want it to be supported for the long term, and you want it to be available for long term. So JavaFX is, I think, in this kind, quite different from many other user interface frameworks, which are mainly out there for a quick win, and which may be very hip or impressive. But the main focus of JavaFX is to be supportable. And if companies or organizations want to have a user interface component that they really want to be available for a very long time, then JavaFX is a great candidate, because we have the same approach here as the core Java. That means that we really avoid making breaking changes, and the same as in the OpenJDK project. This means that there's often a difficult balance between innovation and stability. Of course, we want to innovate as much as possible, but we don't want to break the existing stability. And this is one of the design goals of JavaFX. So it is baked into the development. JavaFX is very predictable. The release cycle follows the same release cycle as the OpenJDK releases, which means that there are major releases every 6 months. And doing so, you can easily calculate when was JavaFX 11 released, or when will JavaFX 21 be released. So JavaFX 17, for example, was released in September 2021. And JavaFX 18 will be released in March 2022. Before we start the release cycle for the next version, we communicate on the OpenJFX dev mailing lists the complete approach, which means that at a given moment there's going to be a feature freeze where we're only going to fix P1 and P2 bugs, and there are 2 ramp down phases, and so that is all very predictable, very transparent and clear. And apart from those 2 major releases for every year, we provide 2 CPU releases for every major release, and those contain security fixes and the limited number of critical fixes that we backport to those CPU releases. Very occasionally, it happens that there are no security fixes, and then we may skip one of those CPU releases. But for example, for JavaFX, JavaFX 17.01 has been released, and JavaFX 17.02 has been recently released as well, and they are freely available. We make a distinction between JavaFX for developers and JavaFX for business goals, because developers typically want to have early access releases. They want to test everything, and business and production environments, they want to have stability and long-term support. Now, in the end, it's about the same code which is available in OpenJDK/JFX. But for developers, we build early access releases from the current head. And that means that we are currently doing JavaFX 18 early access releases, but also JavaFX 19 early access releases, because JavaFX 18 is being branched for stability. So we are working on finalizing 18, while the work on 19 is already in progress. So as a developer, we highly recommend that you use JavaFX 18 and or JavaFX 19 early access builds. These are not purely experimental developer builds. No, they really undergo a large amount of tests, and they are supposed to be stable and mature. We don't recommend to use them in production, but they really should not be showstoppers for production for development. Sorry. So, and if there are issues with these early access builds, we highly encourage developers to report them. And from what we see from the download numbers is that those early access builds are really used very often in JavaFX. So developers really use them. It's actually very simple. If you're using a Maven, for example, then you can declare a dependency on JavaFX for example, 18 EA10, and you will get that early access build. And when there's a new early access build, you just increase that version number, and you will run with you will develop and run with that early access build. For business, we recommend using JavaFX long-term supported builds. And with Gluon, we provide builds for JavaFX 11 and JavaFX 17 as long-term supported builds. And this is really good for customers who want to stick on a supported version and who want to have fixes for that version. And at least equally important, this is the way that currently OpenJFX is mainly funded at Gluon. So the revenues that we get from the long-term support are used to improve JavaFX in general. So it's this is an example of how the ecosystem can give and take. And then, as I said, JavaFX, similar to Java, is more than just a language. With JavaFX, we don't see JavaFX as the end product. If you create an application, a JavaFX application, you can directly use the JavaFX APIs, and I highly recommend that, and many developers do it. But you can also use libraries that are then using the JavaFX APIs, and there are really a large amount of third-party libraries that are created on top of JavaFX. And the first goal of JavaFX is making sure that those library developers can create libraries using the JavaFX APIs. So we try to make sure that what is in the JavaFX APIs and the implementations is generic and maintainable, because we want it to be usable for completely different areas. And therefore, we also try to avoid to be too specific in the JavaFX core, because we don't want, I mean, if there are two totally different market areas with different concepts, it's very hard to come up with a generic component that is usable in both these areas. So we try to stay away from market-specific implementations, but we highly encourage library developers to create APIs and implementations that are really targeting a specific market or a specific area. And therefore, those library developers are really, we consider them as major consumers, and they are really very important in the development of JavaFX, because if what we want to avoid is that they can not do something because of a limitation in JavaFX. So our it's actually the same as in the Java ecosystem. If Java library developers have an issue, or if something in the Java core platform would really help many developers, then chances are reasonable that it will one way or another happen in Java. And it's the same here. If a library developer wants to do something, but yeah, he needs access to some APIs that are not open yet, then that is definitely something that we can do in OpenJFX. So how is the development being done? As I said, it's the code is on GitHub in OpenJDK JFX. Currently, the main contributors to OpenJFX are Gluon and Oracle, and I'm the one of the two project leads, and Kevin Rushworth from Oracle is the other project lead. We have we use the same role system as OpenJDK, which means that we have reviewers and committers, and it's important, and I think it's typical for OpenJFX that we have many individual committers and many committers from small companies that are active in JavaFX. So it's really not controlled by one big company or by a limited number of big companies. It's really different individuals and developers from small companies like Gluon that are working together on JavaFX, and yeah, it's quite special and I really like it. So let's quickly talk a bit about what is planned in the future. Well, we will, of course, and that is always an important goal in every release, we will keep supporting evolutions in operating systems. That actually means that whenever there's a new macOS version, we very often need to change a few things because we use the low-level Mac APIs. And so that is ongoing work that's required in every version of JavaFX. And we consider that extremely important because this is what is guaranteeing the backward compatibility and the stability. We want our APIs to keep working even if the underlying operating systems are evolving. So we want to shield Java developers away from changes in the low-level operating system. And that is something that we take very serious. And that is, I think, one of the key advantages of Java and JavaFX. We provide developers stability. But yeah, it requires work. There's some experimental work being done. For example, there's a sandbox repository that contains an implementation for the metal pipeline rendering, which is getting more popular in macOS land. We're working on a Wayland support, which is getting more important in Linux land. And we're also working on a WebGL pipeline, which I will quickly talk about in next slide. And then we are also improving some basic components in JavaFX, for example, the controls, mainly table view and list view, and they had some technical deficits, and we're working on that. And it's great to see that different people from the community are really working together in fixing bugs in these components. So JavaFX on the web is one of the things that we are trying to move forward. It's currently very experimental work, and it requires two things. First of all, it requires that you can run Java on the web, but not like we had it 25 years ago with applets or with WebStart, which would then launch a virtual machine in or by the browser. What we are doing today is we're using a back to browser, which transpiles Java code into JavaScript code. So the Java code can then run in a JavaScript engine, which is included in all browsers. And the second part that's needed for this is we need to be able to render the JavaFX scene graph. And where we typically do that using, for example, OpenGL or OpenGL ES or Direct3D, on the web, we do that with a WebGL rendering pipeline. There's a website we created for this where you can have a look and maybe contribute if you want. And for example, what you see here is JavaFX on the web with just some basic controls, the clock and the icons and something that's moving. But there's lots of work that needs to be done. But we are really excited about this. So what works currently, some basic user interfaces and animations are working. Compilation time needs to improve. Now that's just a one-time problem. It's only for the developer who needs to compile it. We need full support for Java 17 and a better handling of reflection, and that will also make it much faster, because currently the download size is way too big. But so that is something that we and the community are working on. The ecosystem, I mentioned that a number of times. It's one of the major benefits that JavaFX has. There are two sites that I want to mention here. OpenJFX.io is a site maintained by us at Gluon, but it's community driven. The content is in GitHub, and it provides a getting started website. It doesn't provide much, but what it provides is stable and up to date, and it tells you how to get started and where to find more links. And then there's jfxcentral.com, which is created and maintained by Dirk Klemmerman, which contains much more links and useful information about JavaFX. And then there are a whole bunch of websites with tutorials and screencasts and blogs and so. If you want to help with JavaFX, there are a number of things you can do. You can help the development by going to the GitHub repository and do the regular thing with issues and pull requests. There's one additional requirement here, and that is that issues need to be created in the Java bug system, which is for some people an additional hurdle. So I think we have to work on that. But you can also create libraries on top of JavaFX and report about that. Marketing is also something that we really can use some help with, because JavaFX is really community driven, and that has the advantage that we are totally independent. There is no hidden agenda, and it does what developers want it to do. But the drawback is that we don't have the marketing that other big companies would provide for their UI toolkit. So we, as in the ecosystem, have to do it ourselves. So we're always looking for people or companies to work on that, to write blog posts, tutorials, spread the news with use cases in docs, and so. And if you're a company and you're benefiting from JavaFX, we highly appreciate if you support Gluon, for example, by buying long-term support, where you can find the link there. So in summary, JavaFX provides a mature, stable and reliable set of APIs and implementations for Java client development, and the focus on user interface components. And the development in OpenJFX is completely open and transparent. It's by and for the Java community and the Java ecosystem, and it's not controlled by one big vendor or one big company that may suddenly decide to do something extremely different. And if you're a Java developer, JavaFX is going to be very easy for you, because the familiar and easy approach that you're used to with Java in your favorite IDE works with JavaFX as well. Thanks for listening, and if you have any questions, I'm happy to answer them.